Hi, let's play a rolling dice game. Do you know that the dice has a six-sided dice? Means like each side has some numbers in terms of a dots. 1 dot, 2 dot, 3 dot, 4 dot, 5 dot, 6 dots. A numerically is like a numbers, right? 1, 2, 3, 4, 5, 6. When you roll the die, so you are guesstimating, right? You are likely to see whether you are going to get whatever you wish for. So your probability of getting in the number that you wish is what the outcome of your play. Based out of the outcome, we can decide whether you are going to win or lose from the game. Is it a nice topic for us to understand few concepts of probability? Yes, it is. Hello, welcome to IG Beats for the happy learning. We train, you will get an opportunity to learn some concepts. Okay, without further delay, let's get into the topic. I would like to take a few seconds to let you know that we are now on YouTube channel. Please do visit us at IGBits. We are continuously uploading our sessions to make sure available for you all to access at your own time. One request that I would like to convey through this channel, please do help extend your support to your friend circle to share our knowledge base to help them to build their knowledge. Thank you for so far whatever the help that you've been doing. Continuously do same helping hand to us to build a knowledge base to help everyone. Thank you all. So the probability is the branch of mathematics concerning an events and numerical description of how likely they are to occur. That's the definition of probability. Probability qualifies how likely an event is to occur. Got it? A numerical measure, the numerical value that you are going to assign is ranging from 0 to 1 in the probability. Minimum 0, max 1. These are the two extremes. In the middle, you can get a lot of, a subset of values. 0 means impossible event. That event is never going to happen in that particular scenario. In that case, you say a probability of getting that event is 0. If for sure 100% sure that the event is going to happen, in that case you say the probability is 1, p of a equal to 1. The simple definition for arriving numerical value for degree of uncertainty measure is number of favorable outcomes divided by total number of possible outcomes is nothing but a probability. Probability equal to number of favorable outcomes divided by total number of possible outcomes. Remember, draw inferences about the expected frequency of events is what the probability. You are actually inferring from the experiments and then giving value to a degree of uncertainty is nothing but a probability. Assigning a numerical value to a degree of uncertainty. The concept of probability, when we giving a numerical value to degree of uncertainty measure, what we can do is like we can draw a probability line, and then left extreme point is known as a impossible point, which is a 0 value. Right extreme is like a certainly is going to happen, that is called your prediction is 100% sure thing. So we can say the probability of certainly happening is like 100% likely that is going to happen is what you are trying to say. Whereas in the leftmost impossible cases like 100% unlikely is going to happen is what we are saying. So the probability value for any event that you do is between 0 to 1, impossible to certainly happening case, because we are not talking about 100% sure thing that is going to happen, but we are predicting probably something is going to happen. There is a sure, there is an unsure, right, within your expression. If you look at a, flipping a coin, the coin has two sides that we know, right, head and tail. So when we do experimentation, experiment means like throwing, flipping a coin, and then finding out, like, what is going to see on top of the coin when the experiment is done. So the outcome is either the head or tail. So we have a two cases at any given point of time. When you flip the coin, either you are going to get to see a head or tail, two, right? So those two are called an events. But getting that outcome from that event is what is you are saying is your probability estimation. In our case, because you have a two events, one likely to happen, right? The one would be head or tail, right? So now more likely we say in the value of the probability, if you get the between 1 by 2 to 1, f to 1, that part is called as a likely case, likely to be happening, that the value goes from f towards to the 1. That means like you are going to get a more confident that that is going to happen. That is a case. If you are getting the value lesser side, then what it means, like that's unlikely to be happen case, right. So that means that the degree of uncertainty, you are giving a numerical value to understand the degree of uncertainty in anything that you are predict to happen. So right, if you look at values wise, 0.0 means like impossible, 1.0 is like a certainly correct, 0.50% is like likely or unlikely. This case is only we're talking about a, one of the two events that is going to happen or not happen. The best example is flipping a coin or tossing a coin, whatever it is, 0%, 50%, 100%. This was a concept. Rolling die. So we know the dice and dice game. Dice has a six-sided. Each side actually numbered with the dots is equivalent of like 1, 2, 3, 4, 5, 6. Means there is a six sides and then we have six numbers. So at any given point of time, if you roll the dice, all you are going to get like one of the face towards to you are aimed for. That means like always one event is going to happen out of six. That's an idea. So the total number of possible outcomes in this case is 6, right? So this number in our case is like a 6, but number of favorable outcomes is basically like what you are trying to predict, right? Probability of getting 1, when we throw a die, the probability of favorable outcome for getting 1 is what you are trying to estimate, let's say. So that means like how many ones we have in this one only. So out of 6, one possibility is like getting 1, right? In so based out of a formula probability is nothing but a number of favorable outcomes divided by total number of possible outcomes, right? If you can start it writing, values, right? So then you say probability of getting 1. How do you say the event is going to happen is only 1, the total possible outcomes is 6, like this is 1 by 6. So p of 1 is 1 by 6. Do you get that? Let's try out a, probability of 2. Probability of getting 2 is basically what you're saying is like how many twos we have in six phases, only one. So the favorable outcome is only one, you are going to get it, and then total outcomes from 6. So likewise you see p of 3 is also 1 by 6 because we have one side marked with like a 3 dots. P of 4 is also one event out of 6 events. P of 5, getting P of 5 is also 1 out of 6, and then P of 6 is also 1 out of 6. So what we are saying is that this is all is called your events. Getting 1, getting 2, getting 3, getting 4, getting 5, getting 6. We don't have any other options, right? So this is called a sample space for us. These are the events. These are the sample spaces. These are the outcome of each event, right? This is what your prediction, outcome, result of each experiment that you do. You see that one? And the total possible of outcomes from our experiment is like a 6. This is what you are saying. And then number of favorable outcomes is what you are trying to measure, calculate, right? What is your favorable? So we can also say probability of not getting 1 from your experiment. So if the probability of 1 is 1 by 6, then remaining all is like non-favorable cases, right? So non-favorable cases, how do you see? Total minus 1 by 6, which is nothing but 5 by 6. Not getting 1 is like these are all things. If you can sum them all, how many? 1 by 6 times 5. This is nothing but 5 by 6. Or you can add 1 plus 1 by 6 plus 1 by 6 plus 1 by 6 plus 1 by 6 plus 1 by 6, getting this one. So this is basically probability of not getting 1. It's like a complementary event, complementary to the 1. So this way you can understand all the concepts of the basic concepts of the probability by using a simple experiment known as rolling die. Let's look at now an unbiased die is thrown, let's say. Then we are saying what is the probability of getting an even number. So we know that a dice has a 6-sided dice and then you have 6 numbers. So maximum possible of outcomes every time that you throw a die is one of them. So maximum outcomes is 6 only, right? 1, 2, 3, 4, 5, 6. So total outcomes, if you look at in this case, right? Total outcomes, you say 1, 2, 3, 4, 5 and 6. So this means like 6 outcomes is what is getting. So what we are trying to understand from the problem, favorable outcomes is also we would need to know. How do you get this one? The ask is like even number. How many even numbers I have from the list? 2, 4 and 6, right? That means like these are the 6 events. So now probability calculation, number of favorable outcomes is 3 and then total possible outcomes is 6. So 3 by 6, it implies 3 1 ja, 3 2 ja, so 1 by 2. So our answer, probability of getting even number equal to 1 by 2. Let's say unbiased die is thrown. What is the probability of getting odd numbers? We have to do similar thing what we did in previous case. Right, here also, so total events are, if you see, 6, 1, 2, 3, 4, 5 and 6. So you have a sample space of 6 events. So your n equal to 6. If you look at that way. And then odd numbers. What are the odd numbers? Right? So probable, that is m. So odd numbers means like 1, 3 and 5. So that means m equal to 3. So probability for getting odd numbers is number of favorable outcomes. Our favorable outcomes is basically odd numbers. So the m, total number of outcomes n. So 3 divided by 6. It is nothing but 1 by 2. So this is the answer. Probability of getting odd numbers is 1 by 2 in this experiment. See this problem statement. An unbiased die is thrown. What is the probability of getting a multiple of 3? From the given sample set, we have to look at the condition is given. That is your favorable case. All you are saying is like, you know, your sample space is having 6 events. So 1, 2, 3, 4, 5, 6. And multiple of 3. Find out what is 1 is not multiple of 3. This is not multiple of 3. And then yes, 3 is a multiple of 3 and 6 are the multiple of 3. So all we have is 3 and 6. Right? So that means your m is 2, your n is 6. So probability of multiple of 3, getting multiple of 3 is favorable cases, right? Number of favorable outcomes are 2, total number of possible outcomes are 6. So the answer would be 1 by 3. When you're throwing a die, probability of getting multiple of 3 is 1 by 3. That's your answer. So look at one more case. An unbiased die is thrown. What is the probability of getting even number or a multiple of 3? So here your probability m case, right? M case is basically your favorable case. So your favorable case, what you are saying is even numbers. How many even numbers I have? 2 is a even number, 4 is even number, 6 is an even number from the sample space given. Our sample space is 1, 2, 3, 4, 5, 6. Always remember this is a complete possible outcomes from your experiment using die. So if this is your sample space and then the n is equal to 6 that we know. Now the favorable outcomes you're talking about even numbers, this one, and plus union multiple of 3. Multiple of 3 is like 3 and 6. So the total is 2, 3, 4 and 6 is what is given. This is what your favorable outcomes. So now you say probability favorable outcomes are 4 and then total is 6 and hence 2 by 3, right? 2 2s are 2 3s are. So your probability for getting even number or multiple of 3 is 2 by 3. If somebody is asked, right, not going to get even number or multiple 3 means like complementary of this number. So 1 minus 2 by 3 would be your actual answer. That is how you have to understand, interpret how to derive number of favorable outcomes from the given condition, and hence your calculation of getting probability is easy. Look at this case. What is the probability of getting number greater than 2? Number greater than 2. So your favorable outcomes here, how many? Number greater than 2 means like you are trying to target only these numbers, which is 4. So your m equal to 4 is what is given. So probability means m by n. M means by favorable outcomes which are 4. Total number, basically this total is n equal to 6. So 4 by 6. 2 2s are 2 6 are, so 2 by 3. Right? So this is one special case for our understanding. What we are saying is like, what is the probability of getting even number and multiple of 3? We know even numbers, right, from a given sample set. What are the even numbers? We are talking about 2, 4 and 6 are the even numbers. But what are the multiple of 3 in this even number set? Multiple of 3, right, from this set. How many? Only 6. So our favorable outcome is only 6, because 2 3 are not a multiple of 3, only 6 is a multiple of 3, and hence our favorable outcome is only 1. So now the calculation probability equal to m by n. M means favorable outcome, n means total outcomes. So 1 by 6 is your answer. For unbiased die, if you throw, the probability of getting even number and multiple 3, the probability is 1 by 6. Get it? Let's look at a closer look. An unbiased die is thrown. What is the probability of not getting even number and multiple of 3? That is an ask. So we have to do little groundwork for this one. It is not difficulty, but you need to understand properly. So what is our goal is identifying favorable outcomes, right? So how do you identify them? First of all, even numbers. When you say even numbers, how many even numbers are? 2, 4 and 6 are the even numbers. If you look at a multiple of 3, how many from this? Only 6. But what is asking is not getting not getting not getting multiple of 3. So how do you get it? So total n minus m, total events we know from this, n equal to 6, right? So 6 minus 3, 6 minus this is 1 only, right? Here m means 1, only one event, one outcome. So 6 minus 1 equal to 5. This is not, this is nothing but a not. So now probability, how do you get it? Number of favorable outcomes for not getting is n minus m divided by m, n. So you can say this is a complementary case. So 6 minus 1 by 6, that is nothing but 5 by 6. You could also say total event sample space. If you look at a sample space, total how many you have? 6. And then your favorable case, you are talking about only 1. These are 6. This is 1. So complementary case means not getting 6 is what you are asking. Not getting 6 would be 1, 2, 3, 4 and 5. Right. So if we say probability for not getting case, if you look at that way, so all you have to get it 5 by 6. Direct answer. This is 5. So this sample, this is not probability, this is a sample. I mean, look at this case. What is the probability of getting less than 6? Less than 6 means like only this. You are always trying to get between 1 to 5, including 1 and 5, but not a 6. So your favorable cases are only 5, right? And your total is 6. So 5 by 6 is your answer. So this is the interesting case. Let's look at an unbiased die is thrown. What is the probability of getting 7? Is it not interesting? Who is going to answer me? It's quite simple, but just to understand what are the favorable outcomes. Okay, so try out. So number of events, right? That n equal to 6, that we know, because 1 2 3 4 5 and 6 are the events. But what was an ask is probability of getting 7. So what we have to look at now, favorable outcome. So do you think like you will be able to actually get a 7 from this? Right? So this is a sample space. Within the sample space, I don't think like I have an outcome of 7, right? So if n equals 6, m would be 0 because it's not possible. So if you are getting probability for 7, number of outcomes 0 and then sample space n equal to 6, and hence this is 0. So this is called impossible case. So it's highly difficulty to get a 7 because it does not exist within your possible events. So if you look at a probability line, so 0 and 1, right? And then this is probably F case. So you are actually for sure you are at here. That means like sure thing that this case is not exist. You are not going to get this outcome at all. That is how we can say. So our probability values lies between 0 and 1. So this is the extreme left case, impossible means. I hope you're clear, right? Good. Let's say for example, what is probability of getting any number within 1 to 7 when we rolling the die? See, we have seen that like a dice means all the faces, right? So exist between 1 2 3 4 and 5 and 6, and then what you are asking is like any number between 1 to 6. When you throw a die, for sure you are going to get one of these. What is challenge in that? That means like our favorable outcomes and the number of possible outcomes both are same, right? M equal to 6 and n equal to 6. So probability is 6 by 6, which is nothing but 1. So for sure thing, this case for surely it is going to happen, because your wish is one of the 6 is what you are going to see when you roll the die. So this is not impossible case, this is surely it is going to happen, and hence in the number line this is going to be a certainly happening case. If you look at a number line, right, from the 0 to 1, this is certainly happening case, 100% sure. Thanks for watching. Please like, share, subscribe, click on bell icon and leave the comments. Thank you everyone. Thanks for joining. We shall continue our learning in next class. Stay tuned to next session. See you again.